So this is Notes 13, page 10, part 2. 3 more review problems. And I do tend to put some problems like this on the test. All 3 of these. Just don't be overwhelmed. This problem here is just multi-steps. We're dividing. We see operations inside parentheses, so follow your order of operations inside parentheses first. So your whole world can just be adding those 2 terms. But that's not hard. Common denominator is easy. The only denominator in town is x plus 4, so that's the common denominator. So this is going to be 6 over x plus 4 minus, I'll make that 1 over 1, times x plus 4 over x plus 4. And I know I need to distribute that negative. So it's 6 minus x minus 4 over x plus 4. And so this is just 2 minus x over x plus 4. And I can drop the parentheses at this point if I want, or I can keep them, it doesn't matter, but I've done what's inside the parentheses, so I can drop them if I want. Now, divided by, all right. Now, I need to get this answer inside this parenthesis. So here's my whole world. This is all I have to focus on. Oh, that's an easy LCD. The LCD is just 2x. So I will take this fraction and multiply by x over x. And I will take the second fraction and multiply by 2 over 2. And so I have x squared over 2x minus 4 over 2x. I haven't finished adding, so I need to keep the parentheses. Now it's divided by, this will be x squared minus 4 over 2x. Once I've finished inside the parentheses, I can drop them. Now I'll do the division. If I gave you just this problem to start with, that's a pretty easy division problem. 2 things I need to do: change to multiplying by the reciprocal and make sure everything's factored. So 2 minus x, that's prime. So I'm going to scoop it in parentheses so I can see it as a factor. X plus 4, I can't factor that, so I'm going to scoop it in parentheses so I can see it as a factor. Times, all right, this is the numerator. It's going to go to the denominator, and you should be able to factor that one in your sleep. That's the difference of 2 squares, x minus 2, x plus 2. And then the denominator moves up to the numerator, 2x. Now I look for and cancel identical or opposite factors, and there's not a whole lot of canceling going on here, but see how these 2 factors are flipped around the minus sign? So they are opposite factors. They cancel to a factor of -1, which we typically put in the numerator. And so this final answer is -2x over x plus 4 times x plus 2. So yeah, it's a long problem. 3 steps, but none of those 3 steps was actually hard. You just kind of have to maintain your focus. All right, now, I don't know if you did try these before you turn this video on. If you didn't, try this one. So pause the video and then turn it back on when you think you have the answer. I'm going to go over this. I'm only going to do this one way. And there are some sneaky ways to do this. You could factor this as the difference of 2 squares, and that will actually get you somewhere. You could factor out, create GCFs of c to the negative second and c to the negative first. That's kind of tricksy too. But we've seen enough that you might think to do that. I'm going to do this the way I taught it originally, is I'm going to remove the negative exponents first. but I'm going to be careful when I do that. This is a term. It's not a factor. So I cannot take a term down to the denominator, only factors. So when I remove the negative exponent, I have to remove it right here where that term sits. Same thing here, that's a term. So when I remove the negative exponent, that's 1 over c, I got to keep it right there. So what I really have is a compound fraction. And you know what? This problem is now identical to this one. It really is. It's this divided by that, work inside the parentheses, then divide. So, it's like deja vu. So for the numerator, the LCD is c squared. It's the only denominator in town. And so I'm kind of running out of space. I'm going to multiply this fraction by c squared over c squared. So it's going to be 9c squared over c squared minus 1 over c squared. And so that's going to be 9c squared minus 1 over c squared. Now that's all just the numerator. Now, once you've done inside the parentheses, you can drop the parentheses if you want. Now I need to look at the denominator. The denominator, the LCD is c. That's the only that's the only denominator in town. So the LCD is just c. And I would multiply the 3 over 1 by c over c. So this is going to be 1 over c minus 3c over c. So this is going to be 1 minus 3c all over c. And that time I put the parentheses in, I don't have to have them. But I now essentially, and I'm going to go ahead and put these in here just so you can see the big fraction bar. I essentially have the same situation I had over here. This divided by that. This fraction bar is the division bar. So to do the division, I'm going to multiply by the reciprocal. And I know when I want to cancel, I'm going to need factors. So I see this 9c squared minus 1. That's the difference of 2 squares. I'm going to factor that while I'm at it. So this is 3c minus 1, 3c plus 1 over c squared times, divide by the reciprocal of this, c over 1 minus 3c. And now I look for identical or opposite factors. Too many c's in here. I see that this c cancels with one of those. And I notice that 1 minus 3c, 3c minus 1 are opposite factors, so they're going to cancel to a factor of -1. And so I collect what's left in the numerator, that's -1 times the quantity 3c plus 1. If you want to distribute that negative, you can. And then it's just c in the denominator. That's it. That's what this boils down to. All right? So again, once you got the negative exponents removed, the steps weren't hard. The tricky part about this problem, and I'm probably going to test you on this, is do you recognize that because that's a term, you cannot just flip that down to the denominator because this is not the denominator of that term. As opposed to this problem here. This problem, notice this is all one term in the numerator, all one term in the denominator. This is all one big term. So if I want to remove that negative exponent, that can go to the denominator down here because that is the denominator of the term that 3 to the negative first is in. So other than the fractional exponents, this one's actually much easier. So if you haven't tried it, give it a shot. Pause the video. I'm going to go ahead and start this. This one with all the negative exponents is definitely going to be easier to remove those first. Notice I'm going to draw my fraction bar first so everything sort of can land where it needs to land. The 3 to the negative first is coming down as 3 to the first, x to the negative second is being flipped as x to the second, and the y to the negative first comes down as y. The 8 to the negative 2/3, when I take the reciprocal of that, because this is the numerator of this term, that comes up to the numerator as 8 to the 2/3. The x to the 1/3 doesn't go anywhere. Stays put. The y to the negative 3/2 goes up as y to the 3/2. All right. So, looks a little bit better already. Now we know that fractional exponents are radical in disguise, but when your problem starts with fractional exponents, just work with the exponents, with one exception. If you have a numerical base to a fractional exponent, you are supposed to calculate that. And the way you calculate it is to change to radical form. So remember, the numerator tells you the power, the denominator tells you the root. I'm going to do the root first because that makes life easier. Cube root of 8 is 2, 2 squared is 4. So 8 to the 2/3 is just 4. Okay, now I'm going to look at the y's here. Dividing the same base, subtract the exponents. And this isn't too hard. This is 1.5 minus 1. So that would be y to the positive 1/2 up there. Then for the x's, we're multiplying the same base. When you multiply the same base, you add exponents. And hey, when life is easy, go for it. When you add 2 plus 1/3, that's 2 1/3. And then just realize, oh, I can convert that to an improper fraction. 2 times 3 plus 1 is 7. That's 7/3. So that's going to be x to the 7/3. And you're done. All right, so it really wasn't that bad. All right, one more page of review.